Now, Chris, Marty and I did have to fly onto the carrier and off the carrier, but we were in the back and not in the cockpit. So how do you land a very fast plane on a boat?
Carefully, because, you know, from the altitude looking down at the ship, we used to say it's like a postage stamp, but it's actually 1,000 feet long. It's it's the largest ship on the afloat. But the landing space is, as they say, maybe 700 feet, but in order to land the aircraft successfully, you've got to touch down in a space of just several hundred feet to catch one of 4 cables. If you miss those cables, you got to go full power when you land so that you have enough energy and airspeed to take back off and try it again. So everything is about trying to figure out where you are in that piece of sky, that what you have to do is to get on this part of the deck, and oh, by the way, this ship is moving at the same time. And it's also rocking at the same time. So a lot of things have to go into doing it successfully, but we get a lot of help.
And that sounds a little bit complicated, but I think Marty is going to help us figure out how to do just this with math.
Yeah, so we're going to talk about the math with this, and we're going to talk about coordinates, and I'm going to use a plane to do that, so that means we're talking about coordinate planes. Get it? Math joke? Again, nothing. All right, so one of the neat things about this is that this is real-world math, or a real-world application of something that kids learn in middle school. So what you're learning really has a real-world application. So I want you to imagine that we have a coordinate plane here. Actually, let's actually put the coordinate plane here. Let's do that. Coordinate plane. All right. I'm going to move my airplane back up here to our starting spot. So I've moved the plane back 15 feet and up 8 feet. So we're at 15.8 on our coordinate plane. That's our starting spot. We're going to go over and land on the deck of the aircraft carrier. Now you might be thinking, why aren't we landing at 0, 0? Don't forget, the deck of an aircraft carrier is about 50 feet up off of the ocean floor, or off the ocean. So for our simulation, we've got our aircraft carrier deck about 3 foot up off the ground, so our coordinates over there are 0, 3. Now we're going to calculate the slope using those coordinates. So the first thing we need is our formula. So boom, there's our formula. We've got our second y coordinate, and we subtract our first y coordinate from that. We do the same thing with our x coordinates, and we fill in the numbers, and boom, we've got our numbers, 8 minus 3 over 15 minus 0. We need to do a little bit of math with that. We do the subtraction, and boom, there we have 5 over 15. Now I know all of your teachers will tell you we can't use 5 over 15 because that fraction is not simplified. So when we look at that fraction, I think what goes into both the numerator and the denominator? 5 goes into both. So we do a little math there, and boom, we end up with 1 over 3 as our glide slope, or as our slope here. That tells us something. That tells us that for every 1 foot we go down, we move over 3 feet. And the really cool part is that no matter where on this slope we want to know, we can figure it out if we know the slope of that line. Chris, how'd I do?
Really well. Very, very good. It's very technical, but I will tell you that when we go to flight school, that's what you start with. Because you got to understand that part before you can begin to use instruments and other aids in the cockpit and other technologies. And guess what? Sometimes technologies fail, and so in order for you to have the situational awareness and understand these things, it really starts right where you are today with some basic math.
But let's see if you can actually land it, Marty.
All right, now before we land it, I do want to point out that we've exaggerated the glide slope a little bit. The actual glide slope for an aircraft carrier is 3.5 degrees, which is going to be way down here. This one's a little bit more, but let's see if we can land it here. All right, on the count of 3. 1, 2, 3.
F-18, call the ball. Roger ball. Okay, 3-wire. I wish it were that easy. That's a great demonstration.